We may love talking about the tech found in combat aircraft around here, but the truth is, the most important component is the bag of meat sitting in the cockpit. When it comes to operating some of the most technologically advanced tactical aircraft ever to take to the sky, training is everything. But with today's fighter jets ringing in at between $25,000 and $85,000 per hour to operate, it just makes good sense to do as much training as you can right here on the ground. Militaries around the world have been using flight simulators of one kind or another since 1910. And while advanced fighters like the F-35 may be operating squarely in the 21st century, the projector-based dome simulator systems we use to train their pilots are built upon the same basic technology that's been in use for decades. But last week, I flew out to Orlando to see Lockheed Martin's plan to change all that. Let's talk about how we train pilots to win wars in the sky, and why Lockheed Martin's new Amorphic Appearance Zero Projector Simulator just may be the future of pilot training. I'm Alex Hollings, and this is Air Power. Last week, I traveled to Lockheed Martin's Training and Logistics Solutions facility in Orlando, Florida, to get to be among the first to poke around their new prototype flight training simulator that they've taken to calling AMAZE, short for Amorphic Appearance Zero Projector. Now, this system replaces the sometimes dozens of projectors used in today's flight simulators with LED technology. Now, Lockheed Martin tells me that transitioning to this sort of simulator can dramatically reduce costs, probably by more than a third, all while taking up significantly less space. But when it comes to preparing for combat, saving money and space aren't really the biggest concern. What matters most is effective training. And repeated studies have shown that when it comes to flight simulators, realism is what makes the training effective. And to be honest, that's where Lockheed Martin's AMAZE system really sets itself apart from the sims in use today. But this wouldn't be Air Power if I didn't come with context. So before we talk more about this specific system, let's talk about America's military training advantage and why it's currently in jeopardy, as well as what simulators in general can help us do about this problem. Despite all the money the US invests in technology, there's a valid argument to be made that America's most significant air combat advantage over adversary nations is actually training time. As we discovered in our in-depth analysis of the problems facing Russia's pilot corps in Ukraine, Russian fighter pilots often head into the fight after accumulating as little as just 200 total flight hours. American fighter pilots, on the other hand, regularly log more than 250 hours in training aircraft before even being assigned a fighter to start operational training. But training doesn't come cheap, especially when we're talking about an aircraft like the F-35. It's not enough just to give pilots a great deal of initial training either. In order to maintain the skills required to expertly control $100 million worth of state secrets, hurtling through enemy airspace at 700 miles an hour, all while packing enough firepower to level entire city blocks, require a great deal of maintenance. So, in order to maintain what former Air Force Chief of Staff General David Goldfein described as full-spectrum capable readiness, fighter pilots optimally need at least 200 hours of flight time per year after arriving at their operational units. But that can get expensive fast. The Air Force intends to operate 1,763 F-35As before production concludes, each with a reported operating cost of around $33,000 per flight hour per jet. So a bit of quick back-of-the-envelope math would show us that a target of 200 flight hours times $33,000 per hour means it costs about $6.6 million per pilot per year in aircraft operating costs to stay frosty. And with an eventual fleet of 1,763 F-35s, we're talking about $11.64 billion per year across just the US Air Force to keep F-35 pilots well trained. And while 1,700 F-35s in the Air Force is still a few years out, the reality of pilot training needs may exceed these figures much sooner than that. In April of this year, Luke Air Force Base announced the graduation of the Air Force's 2,000th trained F-35 pilot. But the harsh reality is, American fighter pilots are not getting 200 hours of cockpit time per year. And a big part of the problem is budget. But it's not that the DoD needs more money per se, so much as they just need Congress to do their job. Congress has failed to pass a defense budget until well after the fiscal year it's supposed to be funding has already begun in 14 out of the past 15 years. Each time, the DoD is forced to turn to what they call continual resolution spending, which basically means halting all new programs and only spending enough money to keep the lights on. Now, this is something that former Secretary of Defense and famed Marine General James Mattis once said does more harm to the US military than any adversary he's ever encountered. And I'm inclined to agree. Last year, Air Force officials even told the Wall Street Journal that these now annual funding crises created by lawmakers force it to fund training through a patchwork of stopgap budgets, which in turn results in, quote, a flying hour program well below what is required to maintain high levels of proficiency. But to be clear, they're talking in terms of American training standards and that 200-hour goal. American pilots do still get more cockpit time than their peers, or at least they might. In 2022, Air Force pilots averaged about 10.9 hours of flight time per month, amounting to an average of about 131 hours per year. Now that is perilously close to the 100-hour average from Russian and Chinese air forces, but China has been significantly ramping things up in this regard, and according to some reports, Chinese pilots may already be exceeding 150 hours per year. In other words, America's military training advantage is eroding due to budgetary constraints and political tomfoolery. And while advanced and hyper-realistic simulators can't fix Congress, they can help to offset this problem. High-fidelity simulators give pilots the ability to train in a wide variety of environments and extreme situations for hundreds of dollars per hour rather than tens of thousands. Today, upwards of 45 to 55% of an F-35 pilot's initial platform training can actually be done on the ground in advanced projector-based simulators, and operational pilots can use these same simulators to hone their skills, even when the budget for more real flight training is tied up in Washington. Now, these simulators are designed to be as realistic as possible, with full-sized cockpits surrounded by a dome that's illuminated by sometimes 25 or more projectors. And while real cockpit time is the best way to gain experience, the science at this point clearly shows that incorporating simulator training into a training regime produces better pilots than regimes that train in real aircraft alone. In August of 1990, the Naval Training Systems Center conducted a meta-analysis of 247 studies and peer-reviewed reports all about simulator-based pilot training, ultimately concluding that, quote, the use of simulators consistently produced improvements in training for jets relative to aircraft training only. Now that may seem dated, but a 2016 study published in the Journal of Brain Behavior and Evolution confirmed that pilot performance in testing was highest among those who trained on a combination of real aircraft and simulators. But of course there is nuance to this conversation, and more critical studies, like a 2019 analysis conducted by the Naval Air Warfare Center's Dr. Aaron Judy, along with Southeastern University's Dr. Thomas Gallery, aimed to temper excitement about cost savings provided by these advanced simulators. Their work emphasized the importance of logging real hours in the air, but nonetheless, they still concluded that, quote, flight simulation has definite value in flight training. They went on to argue that what's most important is determining the optimal ratio of flight time to simulator time to get the best results. And while the data overwhelmingly supports the value of flight simulators, it also points to the fact that a simulator's real value is directly related to its realism. As Doctors Judy and Gallery put it in that Naval Air Warfare Center report, whatever the optimal ratios of flight simulation time to actual aircraft time, the review of literature points to the critical need for simulators that are designed for maximum fidelity in order to contribute to pilot competence. Now, today, the US Air Force operates some 2,400 flight simulators around the world, and while some of them are as simple as desktop computers with generic controls, more than 1,500 of them are large-scale projector-based dome systems. Now, this accounts for about 54% of all of these advanced simulators on the planet, but the US still needs more. In 2021, the RAND Corporation published a report on Air Force readiness, highlighting areas in need of improvement and gaps in the branch's overall defensive posture. When asked about how to address these identified gaps, major Air Force commands listed 5 areas in need of increased financial investment, with purchasing more simulators ranking number 2 on their list. But solving this problem isn't as simple as just buying more sims. Today's projector-based dome simulators work by having multiple high-definition projectors displaying overlapping images on the dome around the aircraft cockpit. As a result, these sims take up a great deal of space, and their projectors need a great deal of maintenance. So even if these projector-based simulators were inexpensive enough to just buy more, commands would still need to find a large enough climate-controlled environment to house them in. Now, real estate is always a premium, but this problem is particularly big when it comes to classified simulators. I spoke to Lockheed Martin's Director of Business Development for Training and Logistics Solutions, Eric Rock Etz, about this problem. Now, Etz isn't just some suit at Lockheed Martin. There's a reason this guy's got a call sign. He spent 24 years as a U.S. naval aviator, logging nearly 3,000 hours on the FA-18 and racking up more than 840 carrier landings across 14 different aircraft carriers. This guy knows his stuff, and he explained that they have to treat classified facility space as a constant. It's not going to be expanded, so you just need to work with what you've got. But it's not just size that's the problem, it's also fidelity or realism. Because these projectors need to display overlapping images to create as seamless a picture as possible, issues often arise with projector bulbs coming out of alignment or aging at different rates, creating visual disparities between portions of the screen that can significantly reduce the perceived realism. Think of it like watching a movie in a theater, but instead of one projector, the movie is displayed using 25 different ones with overlapping fields of view. Variances in bulb brightness, contrast, or focus would produce a much more disjointed total image, making it a lot harder to lose yourself in the movie-going experience. Realigning projectors may only take a few hours, but replacing bulbs entirely could take days or even weeks if the parts aren't already on hand. But even when working perfectly, these projector-based systems are not particularly well suited for simulating one of the most common and dangerous combat operations: flying at night. But we'll get back to that in a minute. Lockheed Martin's Amaze simulator aims to overcome these challenges by using more compact LED technology, allowing for more simulators in any given space and a much higher degree of realism, especially in night flying conditions. But to be clear, that's not necessarily all that special. I mean, you could throw a whole pile of money at these problems and solve them a dozen different ways. Heck, if money were no object, you could use Las Vegas's Sphere for one heck of a simulator. But money is an object, even for the most well-funded defense department on the planet, and that is why Amaze is interesting. Not only are we talking about a more realistic simulator that takes up less space, but we're talking about one that should cost about 35% less to operate, or at least that's the plan. And the way Lockheed Martin intends to do so is by leaning away from their historic track record of fielding never-before-seen military technologies and instead trying their best not to invent anything. Amaze may be a new concept, but the tech found inside it is all stuff you can get right off the shelf, just put together in a creative new way that nobody's ever tried before. Starting with replacing projectors with LED screens. Now, LED screens, or light-emitting diode screens, effectively use those diodes as pixels. Each tiny diode contains semiconductor materials like gallium arsenide or gallium phosphide that can emit different colors of light depending on the material and the current that it's exposed to. By controlling the electrical current flowing through each of these diode pixels arranged in a large grid, you can generate highly detailed images with far more brightness and contrast than than can even be accomplished by LCDs or liquid crystal displays, let alone with projectors. But LEDs aren't just better at projecting more realistic imagery, they also last significantly longer than other display technologies. The bulbs in high-definition projectors often need to be replaced after just 3,000 to 5,000 hours of use. Now, LCD screens can often last upwards of 75,000 hours, but LED screens traditionally last for more than 100,000 hours. Now, this means the Amaze Simulator's LED tech effectively eliminates two frequent forms of maintenance that projector-based simulators require. Not only do you have to replace the bulbs from time to time, but more often you have to realign the projectors to fix image fidelity, and that's just something you never need to do with LEDs. But even LEDs wear out, and crazy stuff happens in training environments. Eventually, you're going to have to replace something. And that's actually where the real genius of this Amaze system shines, because despite the fact that it will eventually be a 240 square foot dome, this entire sim uses no large or curved screens whatsoever, as both of those things would make replacing components a lot more expensive and time-consuming. Instead, Lockheed Martin's partial dome prototype actually uses 70 small square LED screens that can be held in the palm of your hand and literally hot swapped while the system is still running. I watched the genius behind this concept, a visual display systems engineer named John Magda, literally yank one of these little screens out while the simulator was running. It just shut off as he removed it, and he was able to just pass it to me to take a look at. The screen was a bit smaller than my daughter's iPad mini, and it was about as thick as my wallet. And when he took it back, he slapped it back into place where it was held there by magnets, and it just lit right back up and showed its portion of the larger image. Now, because it was a classified facility, I was not allowed to record this, and any footage that I do show you in this video had to be cleared through security. But suffice to say that it was a simple enough process that I'm convinced my 6-year-old daughter or a Marine Lance Corporal could do it between juice boxes without much trouble. And importantly, these little square screens are already on the market, so neither Lockheed Martin nor the DoD would need to contract any vendors to produce specialized replacement parts. But by now you may be wondering, how do they make a curved dome screen using a bunch of flat LED panels? And that was a real challenge that Magda overcame using thick fiber optic relays that work almost like a lens everywhere where the screen needs to curve. Now, to be clear, lens might not be the appropriate technical term for these fiber optic relays, but that is just what they look like thick curved lenses pulled right out of a giant pair of glasses. These relays are mounted flush with the flatter screens and curved as necessary with the square LED panel mounted behind them. When the LED screen is turned on, the image it shows is projected through the relay, making it seem as though the relay is the screen. Now that can provide a seamless curved effect without the need for expensive curved screens, provided you compensate for any lensing effect these relays may have, which can be done using software. Now the result is far more realistic imagery displayed around the pilot, especially when it comes to training for nighttime operations. Now, if you've never found yourself in the cockpit of a dark aircraft flying at night, it is hard to describe just how dark everything really is. Obviously, there's reduced visibility, but there are also visual illusions created by the juxtaposition of bright singular lights seemingly hung at random against a backdrop of impenetrable blackness, making it extremely difficult to gauge depth or distance. I'll quote Major Martin Smith, an F-35 pilot instructor with the Air Force's 58th Fighter Squadron. The last-minute cues that a pilot can use to safely maneuver the aircraft are more difficult to detect at night. Everything from reading coordinates on a mission data card to rejoining a visual formation and dealing with emergencies. The things that are automatic during the day require substantial effort at night. But, and there is always a but, despite the added risk and complexity of nighttime flying, the right combination of pilot skill and onboard technology can also turn the darkness into a powerful ally. I'll quote the same Major Smith. when the sun goes down, we are even stealthier and more difficult to detect by our adversaries. Now, as a result, the US has long preferred to leverage its massive air power apparatus at night whenever possible, where advantages provided by stealth, sensor fusion, night vision, infrared targeting are all amplified to their fullest extent. As Etz himself recalled during our conversation, most of the combat missions that he flew in the Navy were all under cover of darkness. And that is a real problem for the projector-based simulators in use today, because projectors work by projecting images in light onto the dome. And when you project black onto the dome, you end up with a very luminous gray instead. Amaze's LED screens, on the other hand, offer 3 times the contrast that's possible using projectors, allowing for much deeper blacks that actually envelop the trainee in darkness. I'll go ahead and quote Lockheed Martin's Etz now. On this display, black is black, so you achieve a level of darkness that's hard to achieve with a projector-based dome system. The ability to train in a really high-fidelity environment is a significant capability, both in terms of visual, unaided nighttime flying, and night vision goggles-assisted or night camera-assisted operations. Those are significant capabilities that this technology jumps right into. Now today, Lockheed Martin has a single partial Amaze simulator prototype, and they're focused primarily on the F-35, but Etz was clear that this simulator technology could be used for all sorts of aircraft and even ground troops like Joint Terminal Attack Controllers, or JTACs. But they're still in the very early stages of development, and for now, no one could say just how long it would be before this Amaze technology could actually find its way into training environments. But because of its use of off-the-shelf technology, it may not be all that far off, and that might be just in time. The F-35 is currently in the midst of Tech Refresh 3, which is a hardware update that will lead to Block 4, which is a group of 75 system upgrades in the aircraft that, among many other things, will allow the F-35 to control AI-enabled drone wingmen flying alongside it, just like the Air Force's Next Generation Air Dominance fighter and the Navy's F/A-XX fighter, both of which are currently in active development. Now, turning every one pilot into a formation of aircraft unto themselves will come with a significant increase in combat capability, but also an increase in cognitive load and stuff the pilot has to keep track of. Leveraging these new capabilities in combat is going to require a ton of highly realistic training. And high-fidelity, low-cost, small-footprint simulators like Amaze really could play a vital role in preparing pilots to meet that challenge. In fact, NGAD pilots could begin training to operate their aircraft in highly realistic simulators before the first serial production jets are even delivered. Ultimately, the more time pilots get in their aircraft, both real and simulated, the more capable they'll be in a fight. And in a world where hours equal dollars, making these simulators smaller and cheaper using off-the-shelf technology so more pilots can have more access to them just seems like a no-brainer to me. And with that ends yet another edition of Air Power from Sandbox News. I'm Alex Hollings. Make sure you swing by sandboxnews.com today and every day for all the latest in news, entertainment, and motivation from all around the force. If you got anything out of today's video, make sure to click like and subscribe down below, and leave me a comment so I know what I should cover next. And of course, don't forget to tap on that bell icon so you never miss a drop from Sandbox News.